Horizontal tangent line of a parametric curve, and previously I gave you a parametric equation, so allow me to scroll up to back to the previous video. So that one is a parametric equation. I use this green table and then I plot the points on an XY plane and then I trace the points, connect them, draw the orientation, and that is the parametric curve of the given parametric equation in green. And then I pick a point at 2, 3. I found the derivative of the parametric curve, and then at this point t is equals to 4, also from the green table, the green t equals to 4 from the table, and then I plug in the t equals to 4 to the slope, to the derivative, and then I found the slope. Now I have a point, I have a slope. You can find the tangent line, and then I plug it into the point slope form, clean up the math, and then I reach to my tangent line, which is right there. That is equation of the tangent line to the parametric curve at point 2, 3. And then I bring back the graph, and then at point 2, 3, I have this tangent line. And then also in differential calculus, we discuss horizontal tangent line, right? So horizontal tangent line is, let's say you have a parabola, and then we all know that this is at this minimum, there is a horizontal tangent line. The horizontal tangent line implies that slope must be equal to 0. So when you hear the word slope in calculus, slope means first derivative. Then you need to set the first derivative equal to 0. Horizontal tangent line. The slope of a horizontal line is 0. The slope of a vertical line is undefined. Okay, the slope of a horizontal line is 0. Just like this parabola, at the minimum, the slope is equal to 0 because there is a horizontal tangent line. And then, is there a horizontal tangent line right there? Let's find out. It looks like there is a horizontal tangent line right there. Okay, just by looking at the graph. Looks like there is a horizontal tangent line right there. Okay, let's do the math. Before we do the math, I need to bring back the slope, the dy dx, that is equals to t to the 3 over 2. You can put that as the square root of t to the third. And then you need to set that equals to 0 because horizontal tangent line, the slope of a horizontal line is equals to 0. So slope equals to 0 when a line is horizontal. That's why we need to set that equals to 0. And then this equation is pretty easy to solve. And then you can see that t must be equal to 0. Okay, I got it. When t is equal to 0, there is a horizontal tangent line. Okay, for t equals to 0, what point is this? Let me go back to my green table. When t is equal to 0, right there. When t is equal to 0, the point is 0, -1. Okay, I will bring this down. Let's use green. So from the green table, when t is equal to 0, the point x comma y is at 0, -1. Okay, I got a slope, I got a point, and then I will use the point slope form, y minus y1 equals to m times x minus x1. Okay, and then we plug in y minus -1. Okay, I can even follow the color, and then equals to slope is 0, and then x minus x1. x1 is x is equals to 0. Okay, and then the right hand side is equals to 0. You have a y plus 1 on the left side. That means y is equals to -1. -1. Y is equals to -1. And then this is a horizontal tangent line to the parametric curve at this point, 0, -1 at that point. So this line is y equals to -1. If you just look at the picture, that makes sense because at that point, the y is always equals to -1. All right, so that is one video for the horizontal tangent line. And sometimes for this type of problem, if the parametric equation is more complicated, this step may take a little bit more effort to do. This step, when you are solving for t, that may take more efforts to do. You may need to do some factors and stuff. So you may need to factor and then use the zero product property to solve for x, because sometimes when the curve is more complicated, you may have more than one horizontal line. It depends. Okay, if the derivative is easy, then solving for t should be very easy. Okay, so that is the end of this video, and then in the next one, back in differential calculus, we introduce concavity, right? Concave up, concave down. Let's also introduce that on parametric equation. Okay, I will see you in that video.